In this problem, we're actually discussing the graphical analysis of the kinematic equations. So we have a particle that travels along a straight line, again, straight line, which means rectilinear and which means a one-dimensional space. With the velocity described by the graph, which is shown here on the right, we're asked to construct the AS graph based on this graph. So again, I'll give you a couple of minutes to try to solve this problem on your own. Otherwise, you can simply continue the video. So let us look first at the graph. We're given a VS graph. We know that it's formed by two different chunks. The first one in which V is equal to 2S plus 4, and the second one in which V is equal to S plus 7. So the very first step is to write down what we actually know to understand and then know which equations we need to use. So we're given V and S, obviously, since it's a VS graph. And we're asked to find the AS graph, so technically A as a function of S. So we want A as a function of S, we have the velocity and the position. It is clear that there is no reference to time, so eventually one needs to make use of the equation that's independent of time. And that's the equation that relates V, S, and A. So from the fundamental equation, one has V dV is equal to A ds. Remember, that's the equation that's independent of time. And so A is equal to V dV over ds. So we now have an expression for A, which is related to V and the derivative of V with respect to S. And that's exactly what we want. So next we can solve for A. Remember, the variation of V is made out of two different chunks. So you need to split up your analysis as well into two. So for S between 0 and 3, that's the first chunk, we have A is obviously equal to V dV over ds. We actually have an expression for V, which is 2S plus 4. We can also get an expression for dV over ds simply by deriving V with respect to S. And so in this case, dV over ds is equal to 2. Then replacing those two values into the equation of A, we get A is equal to 2S plus 4 times 2, which is equal to 4S plus 8. So now we have an expression for A for the very first chunk that goes from 0 to 3. Now considering the second chunk from 3 to 6, A is equal to V dV over ds, where V now is equal to S plus 7, and dV over ds is equal to 1. And so if we replace that into the equation of A, we have S plus 7 times 1, which is equal to S plus 7. Now that we have the two expressions, we need to find the endpoints, like the start and the endpoint for each of the chunks. So let's take at S equals 0 and at S equals 3 for the very first chunk. So in order to get the value of A, we just need to replace S with the respective values. So for S equals to 0, A is equal to 8. And for S is equal to 3, A is equal to 20. So all that was found using the very first equation. Now using the second equation for the second chunk, we need to take the extremities. So S is equal to 3 and S is equal to 6. Now replacing that into the equation, the second equation, in which A is equal to S plus 7, one has A is equal to 10 for S equals to 3, and A is equal to 13 for S is equal to 6. Now, putting all that into a graph, first we mark the different extremities, so the 4 different points we calculated in step 3. Then we can simply draw the line which would represent the two different equations. And so this is how we can actually derive the AS graph from the VS graph. The method is exactly the same for any problem that requires us to derive a graph from another graph. The only difference is which equation to use in step 1. So if we're dealing with a VT graph, we may have to use a different equation which includes time and not position.